So today, so basically today is Python workshop. Yeah, so we're having a case study today, just like an hands-on case study. So like what we did with SQL, if we can remember. So this week we're having a case study in which we actually implement ETL, extraction, transformation, and loading. And today I might be quite fast in some areas. Please, the codes will be actually be provided to us, so we can always try that. Yeah. So today, one of the libraries we are using two basic library today. We are using pandas and NumPy. So both are just Python. They are both are Python libraries basically used for data transformations. So I think we've done something on pandas before. So NumPy. So we'll talk about NumPy now. So NumPy is a powerful Python library used for numerical computing. It provides support for large multi-dimensional arrays and matrices, along with a collection of mathematical functions to operate on this array efficiently. NumPy is widely used in various fields such as data science, machine learning, and scientific computing due to its speed, versatility, and ease of use. So basically, NumPy is just used to run numerical functions, numerical computing in Python. So it's very important. Basically, mainly, especially as a data engineer, we basically use them in Python transformation of Python in feature engineering. So feature engineering, basically, I think we've when we're doing some things on machine learning, we talk about feature engineering. So it's just like you making adding like in short like you making getting a feature um out of the features available in data. So it's just you making calculations out of the features or columns available in the data. For example, feature engineering, maybe we're having um we're having a data that talks about business data, for example, and we have so out of the existing columns in the data, we want to create new ones. So we can definitely use something like feature engineering. So that's it. So, and I told you to install, we use pip. Assuming you want to install any library in Python, maybe pandas, numpy, and different kind of libraries. So we use pip install. That's what you use to install to in Python. If you want to install anything, you use pip install. So, and if you want to use, you use imports. You understand? You use imports to import and you use pip install to install. So we'll do some of that today. So so basic operations of NumPy for data processing. So let's just be fast on this because we still have some hands-on um, coding to do today. So some basic operation in NumPy for data pre-processing include creating arrays, accessing elements with arrays, performing mathematical operation on arrays, and handling missing value. So today, basically, we will handle missing value. So, and NumPy provide function for array manipulation such as reshaping, slicing, concatenation, more, and more, making it essential for data pre-processing tasks. So, those are just basic operation of NumPy. So these are our case study for today. So the case study. So today we are working for Yankee e-commerce. So Yankee e-commerce is an online store specializing in the sale of a diverse range of perfumes and perfume related products. The company aims to provide customers with high quality products from various brands while delivering an exceptional shopping experience. To optimize its operation and enhance customer satisfaction, Yankee e-commerce seek to leverage data-driven insights through advanced data engineering techniques. So we are working for Yankee e-commerce, and from from here we can see it's an online store that specializes in perfume and perfume products. So and so to optimize its operation and enhance customer satisfaction, they are seeking to leverage on data-driven insight through advanced data engineering. So let's go to their business problem. Yankee e-commerce face challenges in effectively managing and analyzing its vast amount of data. So we show that that's okay, including historical sales data, customer information, and inventory data. The company requires efficient data engineering solution to streamline data processing, perform comprehensive analysis, and derive actionable insights to improve decision making process and enhance business performance. So basically, what they just want us to do as data engineer is they want us to build a kind of a system in which all their datas will be well placed and will be ready for different kind of analysis. Yeah, so they'll be able to derive different kind of insight from their analysis. So which can actually helps in the growth of the business. So our objective here is extract historical sales data from CSV file and other relevant sales. Clean and preprocess the extracted data to ensure consistency, accuracy, and completeness. Transform the data using NumPy and Pandas to prepare it for analysis and modeling. Load the processed data into Postgres database for storage and easy access. So today we won't be able to do the GitHub wherever. GitHub is just like a code repository, like where we can store our codes. So as an engineer, you working for a company, when you work on a code, you store in GitHub. So other engineers can actually work on it and make changes. So it will be available on GitHub to make changes. So and we can always store different kind of, even for us as data engineer, we just starting, we can always store all our projects like this project now, we can always store that in GitHub for us to have access to it. And sometimes some employee, if you're applying for some jobs, they might ask you, give us your GitHub or your portfolio. So you can always give your GitHub. That's where your they can always see your projects there. So and that's the usefulness of GitHub. So, okay. So those are the objectives. Those are what we are doing today. And what are the benefits the uh, of the whole process? Improve efficiency in data processing and analysis, enhance data quality and integrity, streamlined data loading and storage process, facilitate collaboration and version control. So version control too can be done through GitHub and connecting to GitHub Actions and Co. So an empowered decision making through data driven insights. So tech stack. So tech stacks means the libraries and the how will I put it? Just like the libraries and the tools. Okay, just like in short, the tools we are to use for this whole project is we are using Python, which is our major coding base. We use NumPy basically for data transformation. We are using Pandas too for data transformation. And GitHub, so we won't be able to do this because of our time. And basically, we'll store into Postgres. So what we are doing today is we are extracting data from a CSV file that we have been given by the company. That's extraction. So the data, we look at the data and we'll do some transformation with the data, like cleaning the data, removing non-value. If they are duplicates, we remove duplicates and so on. So after transforming the data, we will now store into a database, which is Postgres. So that's what we are doing in short today. So like what we did with SQL that we work on the database. So now we are using Python. We'll now use Python to load into the database. So project scope, data extraction from historical data, just like what I said, utilize Python libraries such as pandas for extracting data from CSV file. So we use pandas to do that. Implement efficient data extraction method to handle large volume of historical sales data. Data cleaning and transformation using NumPy and pandas. Utilize NumPy and pandas for data cleaning tasks such as handling missing value, remove duplicate, just like what I said earlier. And we load into Postgres SQL. Use Postgres as a database management system for storing the processed data. Design and implement database schema to accommodate the data structure and relationship. So that's it. So from here, we can create a new folder. Okay, we can create a new folder in our system. So we can actually call it, what should we call it? So let's call it Yankee underscore e-commerce. So let's put case study. No, no need. Let's just put Yankee e-commerce here. Let's create that. And we open. Oh, don't mind me. I wrote Yankee. Actually, we can still work with that. So the first thing we actually do here is okay, let's create our notebook file, IPYNB. So that's it. That's Python notebook file. So we have codes, we have markdown. So let's use our markdown first. So that's it. It's just to make like headings and code data extraction. So now what I do before data extraction and all this, what I do first is I actually make sure all my all how will I call it, all the files I'll be using, in short, or all the data I'll be using, I want it to be inside this my notebook. So instead of referring to somewhere uh in my um in my file, that one will actually be, to call it, actually, to it might be difficult. So I think this the what I just do. Basically, I use a Mac. On Windows, you should be able to do that also. It's just like something like copy and paste. So this is my what's it called? This is my data here. So this is data. I paste it here. Wait, sorry. What I just do in short is bring it here. Yeah, that's what I do here. So very simple. Just bring. It's just like you pressing copy and paste. So I paste it into my VS Code, so my VS Code can see it here. So what I will just do here is let me create something like let me call it data. No, that should be a file. So do this. So let me call this folder data. So this, under this data, I'll create another folder. Let me call raw data. So just to understand, like, okay, this is our data is raw data. And we have under these two is create another file called clean data. No. Okay, let me delete this. Okay, so let me move this into raw data. Yeah, because it is raw. Yeah, I just told these are data here. This is the data, it's rough. So let's extract our data. So basically, so to extract our data, we create what we call you create data frame to import. So what we actually do here is okay, let's import our libraries. So import. Okay, let me do a kind of comment so you understand. Import necessary. To comment, you use your hash key. Necessary libraries. So, oh, what did I do? Oh, I did not change it from Markdown. So I have to change this. You can see this in Markdown. Should be in code. So, so import libraries. Why plain text now? We are using pandas and numpy. So I already have pandas and numpy on my system. So if assuming I want to install now, I'll just say pip install. Let's say pip install. So I'll use this. Let's say numpy. So I use pip to install libraries. So you can see requirements satisfied already. You understand? I already have it. That's why it's right this. So just like okay, if I want to install pandas to pip install pandas, I already have them already. So it's the right requirement satisfied already. You can see because I have them. So that is the installation. So to import is just say to import numpy to import pandas is import pandas as PD and import numpy as np. So that is installation. That's the import. That's how to import libraries. So those are the two libraries we are using basically, pandas and numpy. So to extract the data here, we create a kind of data frame. Let's call our data frame Yankee underscore DF. You can call it anything, but DF has to be there. That's data frame is equal to PD dot that's pandas as PD. You understand? We use pandas to extract. pd dot read. Our file is in CSV. So assuming it's in XLX or something, you would write read dot pd dot read underscore that XLX, but this is CSV. So CSV read underscore CSV, and we do this. So we look for the path of these are raw wherever. So let me copy path. So I will just copy the path and I'll put it here. Put the path here. So I'll copy paste this here. This is the main code here. pd.read underscore it's CSV file. CSV. What this means, I copied the path of this our raw data. And this is the path here. So and we load this. So it's already loaded. So let's check for our data. So we say Yankee underscore df dot head. So let's check the head. This is just to check how data is looks like. Can you see? It gives us the first 5 rows. If I just do dot head, so we can see this is the data. So we can see our data, what it entails. We can see it has non-values. So those are part of the data cleaning we'll do. We can see NaN. It has some non-values in which we have to clean. So another thing is let's check for the columns for the for more information, because we have to understand our data. Because if we don't understand our data, we won't be able to know what to do. Dot info. So let's check some informations. As these are data frame already. So we are calling it. So we want in here dot head, we want the first 5. So we want to visually see the first 5 of the table data table. So here we want information, that's info. So copy that. So from our info here, we can see non-values. We can see it's most of it has 1020. So we can see these first 3, they are 1000. So that means these first 3, they have missing values, non-values. So and that's not much. So actually in analyzing data, you have to understand like, oh, we have just 3 out of how many columns? Out of 19, we have just 3 columns that are dirty. So from there, those columns, we can always find a solution. Okay, what can we do? So let's go to data cleaning or data transformation. Back down here. You delete. When it is much, maybe out of the 20 now, we have like 15, 10 that has the non-values we can fill. But we just have just 3. We drop. Those 3 won't affect our data. So that's very, very good. That's very good. Nice trial. So let's transform our data. Data transformation. So the first thing we do is let's drop non-values. Do you understand? Like, okay, those 3 won't affect. So I'm coming. So we say that's Yankee. Okay, drop, sorry. drop missing values. Yeah, we don't do that. Okay. So that will be Yankee. We call our data frame dot drop now. That's drop missing value. That drop now means drop missing value, and that will be subset. That will be subset equals you open this. And, so what do you want to drop? Order underscore ID, comma, and let's drop two. Let's drop the two and see what will happen first. Customer underscore ID. So okay, are we right? Customer, yeah, underscore ID. So then we do what? Oh, sorry. I know something is wrong here. So don't forget your because it's a yeah. I have to put this. So that will be in place. Because true. So that's the code to drop. So let's see. Yeah. So let's view data information again. As Yankee dot info. Please let's ask questions so you can see that. Because everything is now 1000. Can you see? Because we dropped the missing values already. Wow. That's true. Oh, okay. From here, the state here is even 1009. Yeah, that's true. Okay. Let me try this. Do I need to drop that? I need to fill for the states, but let me drop them. So yeah, can we see that? So that's clean now. If I like, I can fill for the state, but let me just drop. So everything will actually tally. So here, another thing here is, data types, like we said, you can see customer name is object. Yeah, which is right. Product is object. You can see the price here is a float. Yeah, which is right. So you can see price is a float. Quantity is an integer. So we have to check this also. And from here, we can see other dates is an object. No, date can never be an object. So we have to change the data type also. So from there, the date can never be an object. So we have to change the data type from that object to date time. So yeah, so we say that's part of data cleaning. Change the data type for other dates. So, so, so to do that, what we do is call our data frame, and we say that will be okay. What do you want to change? Order dates, yeah. Order underscore dates, yeah. No, yeah, yeah. This is spelling, yeah, yeah. That's right. So we call that is equal to ad dot. That will be to, yeah. We already see that here. So pd dot. So we want to change from object to data time. So we just call our whatever again, our data frame again, Yankee. Think this should use this instead. Yankee. Oh, we order dates. Think we should use double say go here. So so that's that. So yeah, what we did in short here is this is a column. We want to convert the date time, the data type in our data column from object to date time. So this is what we do. From this pd dot to this time. So we use pandas to change to this. So errors is equal to quires means that we don't want any error in doing this. So we run it. So let's check again. Data dot info. No, it's not data, sorry. So we name it Yankee. So you can see date time. It changes. So let's check our data head again. Why am I writing data? Yankee dot head. So you can see there's no missing values anymore. You can see here we have missing values. None, 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 none. So you can see here nothing like that anymore. You can see. So we've actually treated the missing values by dropping. So any question on transformation on this cleaning? So cleaning is still like part of data transformation. So now what we want to do is remember we want to actually this data now we want to put it in um Yankees e-commerce database. So there is what we call there's what we call data modeling, but I don't think we'll actually have time to do that here in class because I'll just show you brief overview on. So we to actually in terms of data modeling before we actually put that into Python, there's what we actually do. I'm coming. Let me try to bring it here and I'll show you how it's done. Let me show you. Yeah, I think this should be hits. Yeah. I've actually done that before, but it might actually take our time. So we have to very we have to be time conscious. So this is it. So I will explain how it is done and just brief overview on how it is done. So here now, what I actually use here is there is a tool called draw.io. Yeah, there's a tool called draw.io. So I'll actually show you how to use that draw.io also, just brief overview, but I won't go too detailed. I won't do all this because of our time. So basically, this is our data here. So out of this data, so out of all these data now, from this, we know we have order ID, customer ID, names, and so we now actually need to put it into different tables. So that's what we do in the draw. We just make the drawing for like assuming if you are working for a company now, okay, and you want to explain to your stakeholder might be senior executive of the company. They don't know Python. You understand? So for them to be able to understand, okay, what have you done to our data? So that's why we put this kind of visualization to like, okay, this is what I did. So in short, what we actually did here is okay, this data, we have order ID, customer ID. So we just see, okay, let's use this instead. Okay, let me just visualize let me just bring out the columns. Dot columns. Yeah, these are the columns names here. So this will be much more easier. So we have customer ID, order ID, customer name. So here from this place, we are like, oh, which tables can we actually create from these columns, from these data columns? We can see. So from here, we have customer name. Why can't we just pick customer table? So we want to put it in different tables. Like, okay, let's create customer table from here. So here we just look at okay, from this from the columns available here for customer table, we know customer ID, yeah, it's tick for customer table. Customer name, it's tick for it sticks for customers table. You understand? What else again? What is actually related to customer here? So we just see everything that is related. I think related. I think phone number, email too is related to customer table. So that's what we did here. So let's see what's in our customers table. Where's it here? You can see customers table. You can see, customer name, email, and phone number. You can see. So okay, we know another thing again from the columns here. We can see shipping address. So we create a table like, oh, why can't we create a table like, okay, shipping address table. So yeah, okay, we know the shipping address table. It will actually have yeah shipping ID because it's shipping address table. Because if you want to ship, okay, you are shipping now. You should have shipping ID, customer ID for customer identification, shipping address definitely where you want to ship to. in which shipping address is also there. We can see shipping address. We need city, we need state, and we need country, and we need postal code. You understand? So those are for the shipping address table. You can see. So it's just from you analyze that from your available columns. That's very, very important. You analyze this from our available columns. So it's not that we are just picking. Okay, out of this, because out of this all big data, okay, to put it, for easy analysis, for example, why we are doing it like this, like for easy analysis, like okay, for example, now is in our database, we have like what we did. If you remember our SQL class, the data is actually divided into different there is a customer stable, there is a product stable, if you remember. So that's we are doing something like that here. And let me just, yeah, thank God we've done that. So we are doing something like that here now. So we want to have our customer stable, we want to have our shipping address stable, we want to have our product stable. So that's what we are doing in short here. So from our column, so it's very much easier if, okay, we want to make analysis concerning the products now, it's just go to the product table. And if you want to join, we can join. You understand? Thank God we've done SQL, so you at least you can actually pick from there. Actually, this table is just for visualization, like okay, just to see what we've done and show connection. These lines, those are the connection between each tables. From our SQL class, we know we have primary key and we have foreign key. So this, for example, customer ID here is a foreign key here and it's a primary key here. You can see that's the connection. So we got all these from our columns. So let me show you how this is done on draw.io. So let me just show you brief, like, because we won't go too deep because of our time. So what's this? So you just go to your browser, just put any, it might be, even if you are using the Windows, just go to draw.io. It will bring this for you. So let's go to draw.io. So we have to create new diagram. So this draw.io. Just go to your browser, just press draw.io. So create blank, and we create. So it tells us, okay, how do we want to store? Okay, let me say, let's start to this. So let's just name it something, Yankee. So this is just for storing. So it comes like this. So this is our draw.io. So to start with this, to make it something like this, to create something like this, like, let me go back to Python. So we call this entity relationship diagram. This is what this visualization, whatever, is called, entity relationship diagram. So to create that on our draw.io now, so we just choose, just from your search, just press entity. Yeah, so entity relation. So it will bring things like that. So I think this, yeah, this is it. Can you see? Ahead. You can see from let's use this. Um, yeah, I think you can see. So let's say we want to create customer product table now. So just write product. We won't be able to finish this because of our time. Underscore df. So that's the name. The primary key here is what? Product ID. So write product ID. Product ID. No, no, okay. So row one here is we have product name. So that's how we do. So it's not something tedious actually. Row 2, what's the name here? Brand. And row 3, category. So that's how we use our dots draw in. That's how we use. So now we want to add. So to add, okay. So let me. So to add, we need more rows here. So to add more rows here, we come to I think that will be arrangements. So we can see here there might be different kind of visualization in different kind of operating system. Assuming if it is in Windows, it's might but you see a kind of drawing like this. Okay, to add up, to to insert row after. So we want to insert row after. We just press this. You can see. So it inserts. So assuming we want to insert row up, so we just press this. So that's very easy. So let's go back. Okay, what's the third? So we insert the rows and we put price. Oh, sorry. It is this should be price. So we are done with that. So can you see? Very simple. So let's just put in one more table. So let's say it's related to okay, let's do order ID. Let's do order table. So we bring in another one. So let's bring it here. So I just want to show you how to connect. So if I can just I'll do this two table and we'll connect. So you see how this line how we actually do this line. So this orders table. So let's orders df and primary key is orders ID. And here we have customer ID. And product ID here. We have quality here. So I want to add more. So how many rows? Let me check. How many rows am I? Two. So let me just add two more. So from arrangements, drop down to 1, 2. So that's it. So I go back to which one is this? Do we have total price? Yeah, finally we have order dates. So that's that. So here we have foreign key. So this is a line. Take it here. Can you see? Actually, you can draw your line anyhow. Let me delete it. So we have products. So that's how to join. So we can do the joining anyhow. So we can. So that's that. So that's that. So that's how to use our draw.io. So when we are done, we just s- do a kind of snapback and we save. So, but we won't be able to complete for this the whole table. So that's in short. That's how to do the draw.io. So you can always go to draw.io and try your hands when you have the data. We have you guys will actually be given the data. You can just try your hands on it. But the whole file will be given to you just to cross check. So that's how to do draw.io. So now let's model for with Python for our customers table. Seems I'll do some kind of copy and paste to make it faster. I will explain that to you, Russ. Because so I don't want to be writing this one after the other. So these are customers table. So what this says in short is we are creating a customer data frame. So from this is our this is our Yankee houses all our data. So now out of all our data that it houses, so what we need here is just customer ID, customer name, email, and phone number. Please, does that make sense? These are data frame. It houses all the data. So out of all those data, what we just need for this customer data frame is customer ID, customer name, email, and phone number. We copy and we drop duplicates and we reset index. Reset index is this customer ID because automatically when you create a new data frame, it automatically creates an index for you. So, but now we want the index should be reset. So that's what we did here. So, and let's run this. So let's visualize. Let's see what's in our customers df dot ed. Can you see that? We reset, yeah, we reset index that okay, we want because normally if we not reset this index, the index will start from this customer ID, and we don't want that. So that's why we reset index. There will be an example I will give out of this that I will make one of the data wherever data columns index. So here we reset index because we want a neutral index. So these are the index. So this is our customers table. So let me write code directly instead of copy and paste for products. So I can copy and paste for others. So products. So products underscore df. That's our products table. So it's equal to just put okay. Let's just do this instead of writing all this. So we just change the so Yankee DF. So what's in our products table? What's in our products? So products, we have products name, brand, category, and price. So we change this to product ID. That's the primary key. Product ID. And this, we change this to product name underscore name. So here we have brand, yeah. Here we have categories. Here we have price. So that's that. We have product ID, product name, brand, category, price. So we understood all this. So let's run. What's happening? What's the problem? What's the problem? Product name. Oh, S. There is no S. Yeah. So that's Python for you. So you can see it says the key error is this. So that's a good thing about VS Code. So it's ran. So any little mistake, it should cause a problem. So let's see what's in our product table. Products df dot ed. So we can see our products table. So that's our products table. So let me just for faster stuff here, let me just copy and paste the remaining tables. So I think this should be yeah. No, not this. Yeah. Let me just copy and paste. So let's do shipping. Yeah, let's do this shipping. Come and see. No, what have I done? Yeah. So this is a shipping address table that we are creating. So here we have customer ID, we have shipping address, we have city, we have state, we have country, we have postal code. So and we drop duplicates, we reset the index. So but here we want to make shipping ID index because I think from our column there's nothing like shipping ID. Yeah, yeah, there's nothing like shipping ID. Yeah, nothing like shipping ID. So we can see. So we have to create. That's why we create this shipping ID and we make it indexed. That okay, we reset okay index. So let's see how it looks. So let's run this and let's see our shipping df dot head. You can see. You can see. Assuming we not reset index now, it will actually put this as the index. So this is a shipping ID. So which other table are we creating? Just I want us to be quite fast because we still have some things to do. So that's the shipping table. This is the orders table. Orders table. So you already know what we did here. So that's the orders table. Is there any other table? Let me just check. Okay, we have payments. So this is the payments. So I think we're done with all our tables. So let's create um a file here that actually we're not creating a folder. Let's create a file here that actually there's clean data. Let's name it clean data. No, it's not done this way. No, it's not what I want. It's a folder. Sorry, clean data. So this is where our clean. We already cleaned the data. So this is where our clean data will be. So so what we want to do now is all our tables we want to store them into. We want to store them into this clean data. We want to make it like okay, we want to transform it to a CSV format. Yeah, we want to make it a CSV format because you already know we already created our tables here. So we want each one of these tables, we want it into a CSV, just like this. Yeah, just like these are our raw data. So we want our clean data here. So what we just do here is just okay. Let me start with customers first before I do copy and paste. So let's say customer df, customer underscore df dot to CSV. Yeah, this is it here. And data just is in a the name of this. Okay, to okay for more. Okay, let me rename this. Rename. Let me make it data sets. Let me name it data sets. So data sets. It's just the path to this. So clean. Can you see? That's the path. So that's the path we want to store the data, the customers' data. So customer.csv. And don't forget it's a path, so we have to columns, columns. So and we actually index first. So we don't want an index. Don't create index for us. So that's the meaning of index first. You can see here we reset index, but here index first. We don't want an index. So let's see. Let's just run this. Let's see what we to do. So let's see data sets, clean data. Can you see? So we store the customer table that we created. We store it into our clean data. So if we just follow this, this is the path. So that's very, very easy. So okay, let me just do this. Okay. To make it easier, let me just copy and paste from no. So from this now we'll see everything will come. So let's load this. What's happening? It's an error here. What's the problem? The problem is from the products. Mm-mm. Okay, let me do this. I don't want to write it one by one. Mm, okay, this one is existing. Uh, okay, let me delete this. I think that's the problem. Ah, there's a glitch somewhere. Okay. Ah, something I did just now. Oh, sorry, it is me. Yeah, I've seen the mistake. So here it's clean data I used here. So there is an underscore here. Yeah, that's something about Python. Any little thing, your code will run. Underscore. You think that's a problem? Yeah. Can we see that? So we already stored them into the clean data. So now the next thing we are doing now is loading into the database. Loading into the database. So so basically what I will do in the loading is still I will just do a kind of copy and paste and I will explain because of our time. So basically we are loading into our Postgres. So I think we use Postgres also for our SQL class. So yeah, so in loading, we are using Psycop G2. There are two libraries we can use. We have SQL Alchemy and we have Psycop G2. So if you want to pip install, it's already there. So I just want to show you we are using pip install Psycop G2. So that's the library we are using. We can use SQL Alchemy also, but we are using Psycop G2 to load into a database. So requirements already satisfied because I already have that. So let me put load in here as a markdown. So this is what we'll do first. So we import this. So let me just copy this. So let me copy and paste this just to make because of our class. So I want us to see everything. So oh sorry. So we import, say import, so I copy to. So after importing this, so yeah, we are storing into our Postgres. So actually, on a real life, if you are working on a real life platform, we don't show this information because these informations are company's personal information. So now if we show this, we're actually breaching or making the information out. So in our codes, because the reason why I'm showing this here is just like a learning platform. It is better for us to see. So in a real life environment, we have what we call virtual environment, and we have .env. We create a virtual environment, and actually all this will be stored in .env. There's a file we create. The file is called .env. So all our secrets will actually be stored there. So we'll now what we just do, we will just create a kind of linkage between our file and .env file. So we call that we just pip install .env. So actually we just load, so we'll be able to load all these as secrets. These secrets, everything should be secret because with this like this, anybody can just sign into our database because these are database informations. So which is not supposed to be out. But reason why I'm doing this here is just like a learning platform, so we'll know how it is done. So yeah, but what? Okay, let me show you our um database to know what we're saying. So this is our database. Let me close this. So okay, okay, let me delete this. So if you want to create a database, and we can use so and here we can use normal this is normal database that these are just a normal Postgres database. This is like a follow com. Okay, let's call it a follow com database. So let's create our own database. If we can remember this, we create database, we give it a name, Yankee. So and we save. What's happening? I think I will need to restart this. Create. Why? Okay, let me just close and start again. These are Postgres pgadmin. Mm. So these are server. I think we use this. Yeah. So let's create. What's happening now? Create this workflow. Okay, it already exists. Sorry, I don't know what's actually wrong with creating, but it should create. But maybe let's use, yeah, it's creating. That's the funniest thing. Imagine it's created. So it's just that it's not. Okay, let me delete this. Let me use ordinary Yankee. Why is this server bringing error? So I want us to use this. So we created a database here. So let's see database information. So these are the informations. Why now? I think this thing is from properties. Yeah. So this is where I get the information. You can see host name, local host, port 5433, username Postgres. So let's go to let me come here. Yeah, you can see this. Let me make this bigger. Hosts, local hosts. So you can see it's just basic information. So which database are we using? Let's use Yankee. So we are using Yankee. So user is Postgres password, in which I'm not supposed to, but no problem. So let's load this. Can you see? So here, let's connect. This is how to connect to our database. Con is equal to get underscore the connection here. So let's connect. Yeah. So we've connected to our database now, to the Yankee database we created. So now we are creating table in which I will need to explain, just like, so now it's just like we are actually writing SQL in Python. Yeah, let me put it that way. What we actually want to do now, we are writing SQL in Python. So don't mind me. Let me just copy this all because it's long. Because if you sit down and be coding this, I think even we'll spend even extra, maybe 1 hour or two. So, and we don't want that. So connected. So I will explain this in which we might have idea. So here you can remember our data definition language in SQL that we are creating we are creating table. So so this is what we did in this is what we are doing in short. We def create table. We connect. We connect this. We connect our database. So this is for connection, and we create table query. So now we are creating schema. Create schema if not exists in Yankee. So if it's not, so we are creating, so we create schema, and actually we drop table like in case. Reason why we are dropping all this in case there is any table that is named this, so we don't want that. So that's why we drop table at first. So it's just like our SQL data definition language. We are creating table, so we create table. If not, like what we did on SQL. In short, if you just see this code, you can see it's something like that. So here you can see primary key. So this one is UUID's unique identifier. That's the meaning of that UUID. So these are primary key. You can see text, text, text. So primary key, you can see price is numeric. If we like, we can put it as a float. You understand? It's just I told you that in our SQL class that you can actually put names in you can these names you can actually put it anyhow so far you are right. As a text, you can put vaca variable characteristic character or something. Yeah. So you can put it there. So it depends on how you want to actually put your stuff. So we create table here just like we did in SQL. That's what we did in short. And we create table on SQL also. So and we close the connection. That's what we did. That's what we did in short. So let's check our Postgres here. So this okay. Schema here. So where's the table? Yeah. So let's refresh and see. Table should actually come out here. Think these are actually having issues. What's the meaning of this? Think the problem is from Postgres because I still use it. Think the problem is from Postgres. So I still use it today. Don't know why is it not coming? Because normally we should see the table here. Okay, let me think Postgres is having issues. Why today? Oh, okay. I think yeah, I think it's here. Yeah. I think it's here already. Can we see? But wait, I'm coming. Postgres is 1%. Yeah, I think this should be okay. Let me refresh. Yeah, so that's that. Can we see? So our data is already in the database already. So even I don't know, something is wrong with Postgres because that's actually what I've actually done before. So after creating table, we insert. So because I don't know, because that's actually what I've actually done before. Well, I don't know why Postgres is not actually loading. Okay, let me do something. I'm coming. Because I don't know what's wrong with. Also, she even drop table when we already have it. I think there's a problem with Postgres. You don't understand what I'm doing here. That's schema. I'm creating a new schema here because that's actually what I've actually done before. Okay, let me see again because I think Postgres is having issues. It shouldn't be even giving errors at all. To create new schema for me now. And it's actually loading. So let me just continue because I don't know. It should create new schema for me. With what I did there. This is actually what I've actually created before. I think Postgres is actually having issues. That's a problem. But it's our assuming if there is an error, this won't actually connect. So let's continue. So after creation, we insert. So let me show you how to insert in Python. So I think Postgres is having a glitch, something. So oh wait, let's do this first. Let's see. Well, it should create. There's a problem. So yeah, the table is not creating. Yeah. There is a problem. Schema does not. Oh, sorry. I have to change this too. Yeah, I think this should. Yeah. So it should create that way. Sorry. I thought I've put this already to create the table. This is just a command to create the table. So I've created a schema. So let's check our database. So let's refresh Postgres. So there should be a new, it's now three. So we now have three schemas here now. So this is Yankee. Yeah, new one created. Yeah, this is what I actually want to do. So let me go. Let's view this. Let's close this. So let's tables. Yeah, we can see we have three tables here. Nothing is inside. Let's check. View. So nothing will be inside this one now. Yeah, yeah. You can see we've created it rows. So nothing is inside. So now let's actually next thing to do is to insert. Because of our time, that's why I'm doing the copy and paste. Yeah. So let me explain this. So it's just like our SQL class, just the way we are inserting. So now what we actually do here is these are database connection. We say try customers. So with we open our customer file, CSV file. We can see this is the path. This is the path to the CSV file. This is the path. So here, when you remember in our Python class, we do something like read. So we want it to read this file for us. So that's the meaning of this R. So after reading, we now want you to copy. You understand? So we now want it to copy. So that's the meaning of copy. cursor.copy. So we copy Yankee dot customer from this. You understand? So that's what we did. So using that with CSV header. So that's what we did here. Same thing with the products. We first read before copy. It's just like you reading a book. Before you read before you actually copy. It's not that you have to read what you're actually doing. So that's what we are commanding our Python to do. So that's what Python did here. So that's the meaning of the code here. So and yeah, after that, want it to connect and you load. This is just like the way we create table here, we load data. So let's run this and see. We can see it's empty. So let's run. Ooh, what's happening? Oh, the same mistake. The way I ran. Yeah. See? So I have to change this to underscore. Just like what happened when we were creating. Because I use clean data straight up from my previous codes. So this is it. So and you have to learn how to understand your codes. Oh, what's the mistake? Because there's no how you code, you will make mistake. That's not possible. You just learn how to read. Error, duplicate key, value, unique constraint, customer p key, primary key. Okay, already exists. Okay, it's telling us it already exists. Duplicate key violated. So let's check. It should work like this because actually I've actually loaded this same data into the database. So that's what it's all about. So let me see whether hmm, why is it not loading? Customer ID already exists. Why? Oh, so another mistake here. To change this because I changed the name. That's the problem. Copy and paste. Yeah, that's it. So another thing, just learn how to read your code whenever there is a mistake. So it's loaded successfully. So let's check. Let's check our table again. So let's refresh. Your first 100. That's it. Any question? Can you see it's loaded successfully? These are customers table. You can see that. Let's see our orders table. Can you see? These are orders table. Everything in our database. payments. Can you see? Completed product table and shopping address. So that is our database. We have everything now in our database. So it will be very easy for Yankee e-commerce to analyze their data, and their data is safe in the database. So clean data in the database. So ready for analysis. Okay, so this will be the end of our class.